So I'm Don Mann with E+ Technology, and this session is 10 gig and fiber channel over Ethernet, real-world design considerations. This is not a sales pitch of any product from anybody. My intent is to talk to you about some of the changes when you move from 1 gig to 10 gig, and some of the things you might want to consider with the different products and how to manage the traffic properly. So quick agenda. I'm going to go through the 1 to 10 gig transition. So what does a 1 gig environment look like and what differs when you look at a 10 gig environment? I'll be going through some cost comparisons very briefly. There's many different ways you can do cost comparisons. I took one angle and hopefully it works for you. I'll be going into some design considerations specific to 10 gig and talking about different hardware components. HP, FlexFabric, Cisco UCS, and standard rack mounts. The concepts apply to any different environment you're looking at with 10 gig. I'll also be talking about traffic shaping and different options you have to manage that traffic when you go from multiple 1 gig links to a single 10 gig link or converged. And lastly, we'll cover fiber channel over Ethernet. Then at the very end, I'll go through the design recommendations, which I think are the meat of the presentation here. Really, some specific recommendations for any environment with 10 gig, and then some specifics with Rackmount, Cisco UCS, and HP FlexFabric. And then we'll close out. I'll try to field questions during the presentation. If you'd like to ask a question, stand up, go to the mic, and I'll try to address it. If time starts to get a little tight, I'll take questions at the end. We'll step out and go over this as long as you guys want. So moving from 1 gig to 10. This is kind of just a simple graphic, but hopefully it gives you a perspective of what we're doing here. With 1 gig designs, anything you look at from VMware best practice, you had separate vSwitches. So you've got a vSwitch for Service Console and vMotion. You've got a separate vSwitch for IP storage or HBAs for fiber channel. And you have a separate vSwitch for your VM traffic. The reason wasn't just to make you buy 6 NICs. The reason was because there's different traffic types on these different components, and it's important to separate those or isolate them and make sure you're not stepping on one another. Most of your designs where you saw vMotion and Service Console on one vSwitch would recommend that vMotion gets prioritized to one NIC and Service Console gets prioritized to another. In the world of 10 gig, you're looking at 2 10 gig links, consolidating all of that traffic onto them. So we need to think about all this different traffic type, and when it's going through 10 gig, how do we manage that properly? Another thing that this slide hopefully gives you a perspective on is cable reduction. So substantial cable reduction when you're moving towards 10 gig. Also in the blades, we're doing over-subscription models with Flex 10 and UCS. So you can substantially reduce your cabling in the data center and make it look a lot nicer and easier to work with. So some of the advantages of 10 gig, one is bandwidth. I mean, it's faster, right? Cool. No, but one of the things to understand is with 1 gig, I think a lot of people think when you bond 1 gig links, you have an aggregate throughput of 4 gig or 6 gig, whatever you're doing with your bonds. Per session, you're not going beyond one single 1 gig link. So IP hash or any of the algorithms out there, your sessions are communicating over a single link. So if you're doing a big copy job or an export or something, you are potentially capping at that 1 gig of throughput. So even if you're bonding 1 gig links together, you're not getting, in all essence, an aggregate of 4 gigs of bandwidth. And so 10 gig allows you that burst when you need it to go faster in those different traffic types. And I think it's very effective for Ethernet-based storage, for different protocols that you're using out there, but you do get that substantial burst of having additional bandwidth per link in 10 gig. So a couple changes with vMotion that have happened over time. 3.5 was 1 gig was the maximum speed you could do a vMotion. You can see that's changed substantially, and it's not just to make it faster. There's benefit. As we're increasing density of workloads, being able to vMotion faster, maintaining chassis faster, keep your workloads balanced a little bit better. Basically, it was funny, last year I presented the same topic. It's changed quite a bit, but I actually submitted the session when it was 4.0 and thinking we needed to worry about 10 gig because of vMotion, and I was wrong. They signed me up for the presentation, but 4.1 came out before VMworld, so that worked well for me. As of 4.1, vMotion can do 8 gigs of throughput on a single vMotion. And if you do 2 vMotions, you'll absolutely saturate that 10 gig link on 4.1 today. And then vSphere 5 is just, if you are interested in vMotion going really fast, it's very cool. With vSphere 5, they have a new feature of multi-NIC vMotion. And the single vMotion, if configured properly, can do 20 gigs. I've done up to 20 gigs. Theoretically, you could do up to 40 gigs of throughput on the single vMotion. I don't know if anybody needs that fast, but 10, 15 gigs, I see vMotions happening in 7 seconds now. So it's pretty cool. You can move workloads around pretty fast. And as you get more dense virtual machines with more memory, that becomes more relevant and more important. I think this is most important when you're looking at maintaining chassis. You want to maintenance 8 nodes, you can do it a lot quicker. You can move your workloads around. This is very important. I think a lot of people, I've seen this misstated. vSphere 5, it's published in books, I think, wrong. It does require multiple VM kernels for multi-NIC vMotion to occur. So that means I have a VM kernel with an IP address for one vMotion link and a separate VM kernel with another IP address for another vMotion link. A lot of the documentation I've read says add 2 NICs into one port group. That does not work. That will not enable multi-NIC vMotion to just have 2 NICs associated with one IP. So you need 2 different VM kernels to do multi-NIC vMotion, or as many as you want to share links with. Number of concurrent vMotions that can occur. This is where you really start getting into saturation, is more than one vMotion, even on 4.1. So on 4.1 with a 10 gig network, you can do up to 8 vMotions at a time. So that means there will be 8 vMotions occurring at the same exact time if you're kicking them off multiple at a time. And so, yeah, just a final repeat there. A single vMotion with vSphere 5 can actually use both links and go very, very fast. I've seen tests with jumbo frames of doing right at 20 gigs of throughput, so 2,200 megabytes per second. You can check that in the VM kernel logs. And I tweeted that a while back. I thought that was pretty cool. And then without jumbo frames, I've seen about 14 to 15 gigabits of throughput with jumbo frames not enabled. So it can go pretty fast. Fault tolerance, this is an interesting topic. Fault tolerance, they generally recommend 10 gig bandwidth in a lot of the guides you see from VMware. How many people are using fault tolerance? I'm curious. Anybody? Effectively? Wow, that's less than last year. That's interesting. 2 hands. Nobody else using fault tolerance? All right, we'll skip this one. No. If you do use, one of the problems with fault tolerance is a single CPU, so they don't support multiple CPUs, and a lot of people doesn't work for a lot of workloads. Just an important understanding of how fault tolerance works. Essentially, it's logging CPU changes, network receive, and disk reads. So if you're looking at calculating how much bandwidth fault tolerance will use, it's essentially the network read, the disk read, and then CPU calculations. So they say basically take disk and net plus 20% for the CPU. So that's how fault tolerance works out algorithmically, but I don't see a lot of people using it today. So if you are, I think it benefits from 10 gig, but we'll move on. Cost comparison. So this is a tough slide for me. There's 1,000 different ways you could do this, but what I did is I took, if you look here, I've got the switch types I use here, so 4948 for 1 gig, and a Nexus for the 10 gig Ethernet, and I looked at this later, I think I should have swapped this, but basically these 2 columns are the 1 gig and 10 gig Ethernet only models, and then these 2 columns here, the second and fourth, would be with SAN-Fabric or FCoE or traditional fiber channel in your environment. So what I did is I took the cost of each component and divided by the amount of ports that were enabled for that device. So 4948 cost divided by 48 times how many links I needed. That's how I came up with my per port cost or per server cost. If you get down to it, you see that the important point here is not that one's cheaper than the other, because this is all list pricing, and you may get better discounting one way or another. But the important point is it's not real far off. So you look at 1 gig versus 10 gig to do a vSphere design, and it's pretty close in cost on a per server basis if you're looking at Nexus Fabric. With fiber channel over Ethernet and traditional 4 1 gig links in SAN, it's darn close. It's within $2 on my list price numbers. So there's not a huge cost to look at 10 gig, in my opinion. And when you really look at the bandwidth you're getting, the cost goes down even more substantial. So 10 gig, you do have that burst capability, and per gigabit, it's significantly cheaper than 1 gig today. So, any questions? Okay. So now we're going to get into design considerations specific to 10 gig. So those are a couple of the advantages. These are some of the changes to vSphere 5 and what you see with some of the major changes in the networking stack of vSphere 5. Not all relevant to this topic, but I think they're all interesting, so I'll go through them just on this one slide. So network I/O control was in 4.1. Some of the interesting changes that I think are really important is the QoS tagging of northbound traffic. And I'll talk about this later, but network I/O control natively does not handle inbound traffic. It is only an outbound algorithm for shares. So they enabled with vSphere 5 quality of service tagging. So you can tag cost values in network I/O control now, enable that on your Nexus switch northbound, and it handles inbound and outbound now. So I think that's a really important feature of network I/O control with vSphere 5. Additionally, with NetIOC, you can enable VM traffic, so you can basically do VM port groups and prioritize one over the other. I don't see a lot of contention in that space, but it's nice to know. And then host-based replication, which is for the host-based replicator of SRM. So replication traffic you can separate out now. LLDP support is something I was looking for last year, and they brought it. For my HP guys, the FlexFabrics, one of the challenges we saw with 4.1, you couldn't really get that visibility of where I was connected in with FlexFabric. As of vSphere 5, they now have LLDP support, so I've got a graph on it. You can basically see your virtual connect information through vSphere, which I think is a nice feature. Additionally, NetFlow and SPAN, I think, are really important features. If you're using NetFlow, there's tons of different NetFlow analyzers out there, but this gives you the ability to see virtual machine traffic statistics and have that dumped out to a flow analyzer. Scrutinizer. There's tons of them out there, a lot of different tools. There's a lot of free ones out there. But this gives you some really cool TCP-based flow statistic information you can get out of vSphere. Simple to turn it on, nice to collect that data. Span, so the mirroring capabilities, basically sniffing. If you need to sniff virtual machines, was not a really easy thing in the past. With vSphere 5, you can turn on VM port mirroring, and it's got a lot of nice options. You can VLAN tag the information. You can put it to a separate NIC and say only allow that communications go through, but very simple setup again with vSphere 5, so the ability to do sniffing of your virtual machines. Metro vMotion, basically increased, and these are all vSphere distributed vSwitch features that require the Enterprise Plus licensing. Metro vMotion supports 10 milliseconds now of doing vMotion between hosts, whereas the current standard with Standard Edition or vSphere 4.1 is 5 milliseconds. Essentially what they're doing there is allowing dynamic buffer changes. They see that additional distance, and the default buffer is 0.5 megabytes, and they can go up to 1.25, which allows you to get up to 10 milliseconds latency. And lastly, multi-NIC vMotion I did highlight is supported on all standard, on all vSwitch capabilities, another feature of vSphere 5. So hardware examples I'm going to cover briefly, but basically the three things I'm going to be focusing on today would be standard Rackmount servers, any vendor, anybody's product on 10 gig. And then the HPC 7000, I'll be highlighting the FlexFabric and talking about some things you need to think about when you're doing FlexFabric. And then with Cisco UCS, I'm focusing on the virtual interface card, which is the Cisco card that's offered in the UCS capabilities. Both these products, you can do other components, other switches. They end up looking more similar to Rackmount Server, so it should fit well into the Rackmount Server discussion. So standard rack mount, the important thing I really want to focus on here, basically you're looking at servers that would be plugged into a data center class 10 gig switch. Here I'm referencing the 5548 Nexus switches. The important thing to understand here is you do not need to upgrade your core if you're looking to leverage 10 gig for vSphere. A lot of the benefits of 10 gig Ethernet are for vMotions and traffic amongst those ESX hosts, and also if you're using Ethernet storage going to your storage fabric. So you can do all that right in the data center, and you can or don't have to upgrade your core 6500 or 7Ks, and if you needed to, you could still go over 1 gig potentially if that's the bandwidth you need, or bonded 1 gig links up to the core. So a lot of the advantages in 10 gig Ethernet are, for me right now with vSphere, are in that local data center. So these are not, they're relatively inexpensive switches to look at as part of that upgrade cost. So with HP FlexFabric, I'm going to cover just one slide from HP and Cisco right now to explain the card capabilities, and when we get into recommendations, I dive into both in more detail. With HP FlexFabric, essentially in the olden days with HP, we were doing multiple bays in the back of the HP chassis, and we were doing 1 gig links. With FlexFabric, you're now looking at basically populating bays 1 and 2, so just 2 switches. And essentially you take 10 gig links and you carve them up with the bandwidth that you choose. So you see here I'm giving 2 NICs to the service console, or management console. Virtual machine traffic, 2.5 gigs. vMotion, 3 gigs on each of the NICs, and then storage still has 4 gigs. And those are flexible. You can change those on the fly. You can tweak these numbers. I believe in the recommendations I see from HP, right now they've got vMotion at 1 gig. I think with vSphere 5 and multi-NIC vMotion and moving towards more and more density, you can give that a little bit more bandwidth, and you're not really starving anybody out here. I'll take a second to talk about this now. I've done a lot of studies of virtual workloads, and there's a lot of burst, but the majority of virtual machines are averaging very small amounts of bandwidth on the wire. So a lot of people think they need tons of bandwidth for VM traffic or even less for storage. What I saw, we grabbed about 15,000 workloads, and the network traffic average across all those virtual workloads was 1.8 megabits per second on average. And then the storage was slightly higher at about 3.5 megabits per second. So I usually average about 5 megabits per virtual machine. And again, those are averages, not your peaks and bursts. Those are certainly going to go faster. But across a ton of workloads, we're averaging a very small amount of bandwidth. So you've got room in here with 2.5 gigs on the virtual machine traffic, and we can give vMotion a little bit of room to move quickly across the chassis. So Cisco, their approach to doing some 10 gig design is the virtual interface card, also referred to as Palo. I think that was the product name before it released. Virtual interface card or Palo. The way they approach 10 gig is based on quality of service. And so what you're doing here is you've got 2 different fabrics, Fabric A and Fabric B. I'll talk about there's different approaches to using Cisco with the VMFX technology. What I see most commonly deployed today is what we call adapter VMFX. What I'm doing here is I'm giving, through the Palo card, I'm giving myself multiple vNICs. So I've got 4 vNICs on each fabric, and then I'm applying quality of service to those and a minimum bandwidth guarantee to each. So I basically have separate vNICs for the management console, separate vNICs for VM data, vMotion, and then NFS or something else if you want to leverage additional NICs. And then what we do is we apply quality of service tags to those. So cost value of gold, silver, best effort, platinum, and then this minimum bandwidth guarantee. And that's the weight you'll see in another slide as well. What you're doing there is you're basically saying half a gig for management traffic at a minimum. I'm going to give 2.5 gigs to virtual machine traffic. I'm going to give 1 gig minimum guarantee to vMotion, but it allows it to burst. It can go above that 1 gig. So we're giving it the minimum guarantee and allowing it to use that excess space. And then we can carve up storage however we like. In this scenario, you'd be more NFS heavy. You can tweak those numbers all day long. So that's how the Cisco product works. It's a very interesting approach to prioritization. So traffic policies. This is kind of all the different traffic that you can think about you might see in a vSphere environment and the different ways you might think about this traffic. So management's pretty low utilization, but relatively high importance. I've heard some confusion with vSphere 5 and the whole storage HA functionality of detecting HA isolation events through storage. I still think management traffic's important. When you saturate traffic where management is, you'll start to get IP timeouts. You'll see hosts disappearing off the line. Certain tasks will start to potentially fail. So relatively high importance, very low utilization. So I like to give it a little bit of priority on the wire. Storage, I generally refer to Ethernet storage or FCoE as very high importance. Everything's relying on storage if you're hosting those virtual machines, so I think it needs to be high importance on the wire. Virtual machine traffic could be low or moderate utilization, and the importance can vary, but generally I would put it as lower priority than management and the back-end storage traffic, because if you don't have storage, you don't have management, potentially your virtual machines won't be available to you either way. Other traffic types we have is potentially fault tolerance. We have fiber channel or Ethernet. This is important. Some of the products that we're looking at are not aware of FCoE. So VMware's network I/O control is not FCoE aware. It doesn't know about the FCoE wire underneath if you're using FCoE. From what I'm seeing and what I'm understanding through talking with VMware, that doesn't really hurt anything as long as you manage your shares properly and understand that. But just know FCoE could potentially be on that wire as well if you're using it, and things like NetIO control are not aware of FCoE. And then the last thing I want to focus on here is vMotion. vMotion is very spiky. It will use as much bandwidth as you will let it. And that's a good thing. It allows you to move your data around a lot quicker, but it's something you need to be aware of and manage properly. So there's two different core approaches to managing that traffic on 10 gig. I've kind of categorized them. We could use different wording, but basically I call it traffic throttling, which is the capping the amount of speed that a single portion of your traffic can do. So I refer to that as throttling. And then traffic prioritization is where you're setting those minimum guarantees and allowing the traffic to burst as needed. So examples of traffic throttling would be the standard vSwitch. You can manage 10 gig with the standard vSwitch just fine. What you need to do is you need to throttle that traffic that you're concerned about saturating the links like a vMotion. So you need to make sure you cap it at 3 gigs or 4 gigs. I like to focus on 3 gigs in that space. The distributed vSwitch without network I/O control enabled is also an example of throttling. So with distributed vSwitch, you can do that same capping capability as you can with the standard vSwitch. And then lastly, the HP FlexFabric today, basically what they're doing is they're setting bandwidth speeds per FlexNIC. So you can do 4 FlexNICs per FlexFabric, and you're saying this FlexNIC is going to go 2 gigs, and this is going to go 3. So it's another example of traffic throttling. Traffic prioritization would be distributed vSwitch with network I/O control. So you can set those shares that we'll go over in a few slides and allow your bandwidth to exceed that share value if there's extra bandwidth available on the wire. And then Cisco Nexus 1000V has, as of 1.4, has to be able to do weighted fair queuing. So we can actually do bandwidth priority in Nexus 1000V. And then lastly, as the slide I showed you earlier, with the Cisco Virtual Interface card, you can set prioritization and allow that traffic to exceed that minimum bandwidth guarantee. So with vSphere, you have 3 different options, and I'll take a step to mention here. I presented this topic last year as well, and I've cut out some of my core 101 networking that was in the slides last year. If you'd like that, you can download the material from last year if you attend the conference. Just in the interest of time and getting to the recommendations, I covered standard vSwitch and DVS and 1000V in a little bit more detail last year. So the 3 different switch options you have in vSphere, standard vSwitch is basic. We've all seen it. It's what we've been familiar with for many different years. The distributed vSwitch essentially is what it's doing is managing that vSwitch at a cluster level and setting policy across the cluster. You set what you want to do, your NIC policies, and it's going to establish that across all hosts. The features you want to be aware of with distributed vSwitch would be some of the stuff I mentioned earlier, network I/O control. I call it data center quality of service now that I can do those QoS tags in net I/O control. The span or DV mirror functionality, NetFlow, and then private VLANs. I don't think a lot of people are always aware of. I think private VLANs are a nice option for different designs. Private VLANs are a feature enabled with distributed vSwitch, end up. Additionally, if you choose to, you can add the Nexus 1000V on top of that distributed vSwitch. It requires VDS underneath. 1000V, I think the biggest thing I see people leveraging 1000V for, especially with the 1010 appliance, is to really give the network team the control of that networking environment. Allow the network team to have a complete Cisco interface and functionality. But I like the 1010 a lot, and you can get bundles where it's actually not very expensive. And the 1010 allows you that hardware appliance they can console in, plug into their console servers, and have that hardware node that they're doing our management through, and then managing the virtual Ethernet modules in ESX. Additionally, 1000V has some additional components you can add on: the virtual security gateway, network analysis module, and I imagine there's going to be more in the future, add-ons to the 1000V functionality from Cisco. Network I/O control. This is a great slide to really explain what happens with vMotion if it goes unmanaged. What we're seeing here is with network I/O control turned off and not enabled and shares not allocated properly, basically we're averaging 1 gig of throughput on all these different traffic types. We've got NFS, virtual machine traffic, and a few others. So they're running about at 1 gig. You kick off vMotion with network I/O control not enabled, and we saturate that 10 gig link. And you see the traffic starting to peak up at 10 gig here, and the other traffic drops to nearly zero. So that's what happens when you turn on something like vMotion and you're not controlling the rest of your traffic, because it's massive packet load, it's massive, it's trying to push a ton of data through the wire, and it's going to step on your other traffic. And I've seen this time and time again. I use simple tools like JPerf or iPerf, NetPerf, just generate a little bit of traffic on the wire and watch what happens. But if you turn nothing on, you will absolutely see your virtual machine traffic drop to nearly zero with nothing configured properly. This is the case for any of the products we're talking about. They're all able to manage it, but you do need to do something. And this is what it looks like with network I/O control enabled. So we're still maintaining that 1 gig of throughput for the different protocols. vMotion kicks off. You see we can still get nearly 10 gigs of throughput, and vMotion is capped at the excess bandwidth that was available. So it can go as fast as it can, but it doesn't exceed and step on the rest of the traffic. So that's with network I/O control enabled with these share values here. I have some different share values, but really the importance is making sure you're enabling that IOC and setting some decent share values. And I'll talk about a formula for doing that later. I think this is very important, especially when you look at blades. It's not just vSphere. So network I/O control sits at the host level, and it's looking at setting value there. I like with vSphere 5 now I can set those cost values and be more data center centric. Important thing to understand with blades, I've seen even in the 1 gig models, I saw HP blades with 16 hosts in there on 1 gig back in the days when we were doing the Cisco 3020s or something in there, and one 1 gig link, leaving the whole chassis. You're doing a lot of oversubscription. It's very important to be aware of that oversubscription between the blades leaving the chassis. If you're leveraging these products, FlexFabric or the Cisco Virtual Interface Card, they can help with that oversubscription and make that safer, but be aware of it. It's not just the ESX host with network I/O controller shaping. You need to look at all your links throughout the data center and see where you might have congestion occurring. And also, once again, you do get a lot of benefit from Ethernet-based storage benefiting from 10 gig. If you're doing exports, big copy jobs, big backups, that sort of stuff. Another thing I want to point out here is not being all about ESX. You do need to think about your traffic node failure detection. So if you lose a switch or a port, you need to think about how is my virtual machine traffic going to fail over. Ways of leveraging that in most cases would be with Cisco, the link state tracking functionality I'll show you. ESX, you have beacon probing, so you can turn on beacon probing. It's a good backup. And then with HP, you've got Smart Link functionality in FlexFabric, so you can turn those functionalities on. And if they notice an upstream switch failure, they'll down the ports on the ESX host and force the traffic to fail over quicker. So these are good things that I think you should be turning on. I don't see them enabled in all cases. Cisco, it's link state tracking, and HP, it's Smart Links. There's usually a solution in any of the blade vendors for that functionality. Without blades, generally beacon probing is your best approach. Or 1000V has a similar functionality of beacon probing a little quicker from what I've seen. So a simple slide on quality of service. I don't know if it's actually simple. It's kind of ugly. But quality of service, the thing I want to point out here is what TrueQoS is doing is establishing separate buffer queues. So when we see these cost values of 1, 2, 3, 4, 5, 3 for fiber channel, these are physically separate buffers on that Cisco VIC interface card. So I'm sending traffic through one, and I'm starting to reach congestion or saturate that link. I'm going to buffer in that queue, but the other queues can move through cleanly. And so what quality of service is doing is establishing different queues with different buffers. So as you start to saturate one, you're not impacting the other traffic, and you simply send a pause back to that single quality of service queue. And then you can do things like allow burst, allow your traffic to exceed that minimum bandwidth guarantee, but not step on the other traffic, leveraging the cost values. So fiber channel or Ethernet. How many came to hear about fiber channel or Ethernet? All right, that's better than fault tolerance, right? So FCoE, a lot of people are waiting on multi-hop FCoE. I honestly, I would like to see further development in the FCoE stack, but I'm very happy with FCoE that I've seen today, helping with host initiators and cable reduction and simplification of the SAN. The big difference in FCoE and traditional fiber channel is the media that it's going over and the simple layer 2 protocols that are occurring down there. So FCoE, from a look and feel perspective, when you're managing it, looks very similar to fiber channel. But essentially the big difference is on traditional fiber channel, physical wire, you plug in fiber channel and you're using fiber channel protocol all the way up the stack. With FCoE, you're sitting on Ethernet wire, data center bridging standards, and right above that, you're sitting at the FCoE protocol stack. There's some performance differences and variation, but the important thing is I think a lot of people want to understand the difference between iSCSI and FCoE. They both go really fast. They both do really well. FCoE is a little bit lower latency sometimes from what I understand and what I've seen. But more than anything, if your traditional SAN shop, FCoE works very well. Look and feel is going to be very similar to traditional fiber channel. Register state change notifications, same zoning concepts you're looking at with traditional fiber channel, works really well. The big difference is you're leveraging priority flow control, which is a standard with data center bridging and data center Ethernet, which basically sends those pause frames. So FCoE sits in the cost value of 3. It's a no-drop queue. And if it starts to see congestion, it's going to pause and send a pause back to the host and tell it to slow down a little bit. That's the only major change between that and traditional fiber channel, which is buffer credits that you're leveraging in a traditional SAN. But very, very similar look and feel. Performance I've found to be very solid. I'm not really that concerned with multi-hop FCoE. I'm leveraging the blade technologies or CNA cards, and then you can connect to your SAN over traditional fiber channel. So some people, I had an interesting question of, 3PAR or some SAN vendor that's not supporting FCoE today. Your host can do FCoE, and from that FlexFabric or Cisco Fabric Interconnect, you connect over a fiber channel back to your SAN, and it looks and feels and looks just like fiber channel. It works very well. So, any questions? I think that's the core stuff on FCoE, and then I'll talk about some stuff in the recommendations. What do you do on time? Good. I talk kind of fast. Good. We've had no questions either, so that's interesting. Design recommendations. So I'm going to go through some general recommendations of things you want to think about in your network anywhere, anytime. I'm going to talk about Rackmount Server specific options there. And I'll go through FlexFabric, UCS, and then I'll touch on 1000V because it can kind of intermix through a lot of these different options. I'll just let you guys read that. It's a busy slide. No. So general recommendations, I think it's got a little longer from last year. Read best practices, but they are not, in my opinion, the Bible of design. Best practices are good for you to understand what vendors are suggesting and recommending, but you need to take that into consideration in your environment and make the decisions that are best for your world. I've not seen a single best practice that works for every customer. But really, you do need to read them. You need to be aware of them and look at all the different options and read the different best practices out there. But you have to make your own decisions or work with a partner or the vendors themselves to make design specific to your environment. Check the hardware compatibility list. This is a very important topic. What comes out as the drivers in vSphere are not always the drivers you want to be running for your network cards. And so check your ACLs for firmware and drivers. Make sure you're looking at the difference between the inbox and async drivers and what are the features. There are some cards that really we need to download the drivers and implement the drivers properly after vSphere, the basic driver that's in vSphere. So check the HCLs with vSphere, look at your card, and see what they're recommending for the drivers and firmware. What's beacon probing? So I talked about link state tracking, beacon probing. Make sure you're doing something to detect northbound fabric detection failure. VMXNet 3 where possible. I see a ton of virtual machine templates that are using the E1000 driver stack. And it's more efficient to use VMXNet 3. It's more CPU efficient. Can go faster. I don't see a lot of reasons not to be using VMXNet 3. So look at your templates and make sure you're using the right driver stack. So that's under the virtual machine properties on the NIC. If it's using E1000, you'll have to remove the NIC and add one with VMXNet 3. But it's a more efficient driver stack for your virtual machines as long as you have VM tools installed properly. Leverage twin-X cables. So when you're looking at 10 gig, this is really important. Fiber channel cables are expensive, and the optics are really expensive. It costs a lot of money to make those optics. In data center bridging, there is a twin-X cable that goes up to 10 meters. Both HP and Cisco and CNA cards can all support these. They're quite a bit lower in cost. So those cables are usually $120 to $200. You take the optics and the fiber cables, and you're talking substantially more cost. You do need to leverage the optics and fiber channel when you need to go over longer distances. But in your data center, try to leverage those twin-X cables where possible. And we've even seen sometimes it's cheaper to buy an additional stacked switch in the rack to use those additional cables. It's such a difference in cost. And make sure you're getting the right ones. Most of the vendors are good about supporting each other now. There's a couple challenges in there, so verify that what you're plugging into is going to support that cable from that particular vendor. But those Twin-X cables are substantially cheaper than leveraging traditional optic. And early on, we had some challenges with them. They've been pretty stable and pretty good for us and our customers now. Jumbo frames. That's an interesting discussion, and you all may agree or disagree, but I'm right now suggesting that use them sparingly. I don't think you need jumbo frames in the data center. Traffic is moving darn quick with 1,500 MTU size. But the reason I say this is I turned it on and did some testing. And when you start doing that bandwidth prioritization or getting that additional space, I see jumbo frames with larger packets, larger buffers. It starts to step on the other traffic a little bit more. It's a little bit harder for them to manage 9,000 byte packets fighting against 1,500 byte packets. And where people want to turn it on is vMotion. I will tell you, it goes really fast when you do. It's cool. It went from 15 gigabits on multi-NIC vMotion with MTU size of 1,500 to about 20. I mean, saturating the link with jumbo frames. But generally, I refer to vMotion as the lowest priority in the link, and I don't want to see it fighting with anything else and winning. So I would generally recommend not using jumbo frames for that purpose. If you need them, just test it, look at it, verify your traffic, verify things are working properly, and verify it's working as desired. Test everything. Test failure, test traffic, saturate your links, saturate your storage array if you can. If you're building out a new environment, try to test it. See a lot of stuff come through. People in a hurry, they deploy it and they roll it out in production. But if people are doing tests, I see people failing a host or pulling a cable. But try to saturate your links and see what's going on there with tools like NetPerf or JPerf or Iometer on the disk side. Try to get your links to saturate and see what you can do for bandwidth and just make sure it's working as desired. Historically, last year I had some cards that I really wasn't seeing that they were able to get up to 10 gigs. This year, all the cards I've tested on the HP and Cisco side are able to get up to the speeds that they're saying and working really well. But it's important to test them every time. Make sure your environment's working properly. Spanning tree port fast, I think this gets missed sometimes, but everybody's best practice recommendation for VMware, Cisco, HP is to enable spanning tree port fast. It basically doesn't force you to go through the whole entire spanning tree process because those ports aren't switches. They're just hosts dropping on the wire. It makes your failover and detections faster. You'll have issues if you don't turn on spanning tree port fast sometimes. It's kind of weird. What's that? Turning off STP everywhere? The important thing is on the host side to turn off, enable port fast or disable spanning tree. I've not always heard that, but if you're using spanning tree, make sure you turn on port fast on the ESX hosts. VLAN tag, this is something I like. Most people are working day in and day out in vSphere or the networking teams working on their network switches. I see a lot of VMware environments where they assign one VLAN to each of the NICs, and there's no VLAN tag information in vSphere. So if you get into troubleshooting mode and you're talking with your network team, they're like, well, what VLAN is it? And we end up scratching our heads. I like tagging everything into my vSphere environments and being able to see all the VLANs in vSphere. Standard vSwitch was really nice because it showed it right there. But I like giving that VLAN visibility in vSphere so when you're troubleshooting or talking, you know what VLAN all your different traffic types are in. So my suggestion is to tag VLANs right into vSphere. You don't tag it to the virtual machines. You assign it to the port groups. It works really well. And it gives you that visibility of what VLAN you're referring to when you're discussing something with your networking team. And if you're looking at vSphere 5, I've found multi-NIC vMotion to be very robust and very solid. On any of these recommendations, you can cap it. But why not spread that love across the two different links and do a little balanced distribution? It works really well from my testing. So. And again, just read the documentation out there, read everything you can find, but it really comes down to you to work out your designs properly with the people you're working with. So Rackmount Server specifics. I like network I/O control if you've got distributed vSwitch. You certainly, with standard vSwitch, can rate limit and cap your traffic to not saturate that link. But if you've got network I/O control, you can allow that burst, those share priority levels, and allow your traffic to exceed that minimum guarantee, which I think is a nice option. Or throttle at 3 to 4 gigs if you're using standard vSwitch or not leveraging NetIOC. If you are using NetIOC, looks like I didn't. Enable QoS priority tags. I think that's really important. NetIOC is outbound only. If you read VMware's NetIOC best practice guide, they say if you're really concerned, they say to cap it inbound. The other option is to enable those cost values and configure your upstream switch properly. So if you configure that quality of service, the northbound switch, when it's sending traffic into the next host, the receiving host, it can verify that link's not getting saturated there and ensure the same priorities inbound as it's doing outbound. The reason for that is you're not just talking to each other. There's different amounts of traffic going out of the wire. So sending from one host to another, he's got 8 gigs available. There might be more traffic on the receiving host, and you would potentially saturate there. So inbound traffic shaping, or leverage those cost values and configure your northbound switch properly. In my references, I have a simple quality of service config that you can paste right into a 5K, and you can tweak it as needed. And I'll show that. Optionally on Rackmount servers, you can upgrade to the 1000V to get that network team visibility, VM level quality of service. You can do VM port profiles in 1000V and do quality of service down to an individual VM, and leverage features like the virtual security gateway if you desire. So these are the network I/O control configurations that I've recommended. I also have a spreadsheet that you can tweak some of these if you want. And right here you see those quality of service priority tags. So the different cost values, 5, 4, 4, 2, 1. I've combined management and fault tolerance because, again, I don't really see fault tolerance very commonly used. But if you're using it, it's similar importance level to the management traffic. But it's very important, in my opinion, to configure those quality of service tags or look at that inbound traffic shaping of vMotion. So HP FlexFabric specific. This slide, this is one thing I see with HP is people get a little bit confused with shared uplink sets and VLAN tags and how it all works. So I put this up here to hopefully explain some of this. If you're looking at the cabling of a chassis, they have a stacking guide, which is pretty good, and also the FlexFabric cookbook that's in my references. But here, basically, I just want to simply explain this. So generally, when you're looking at FlexFabric or Flex10, you're stacking your chassis if you have multiple chassis. So you have 2 cables going between the chassis. And then if you're using FCoE, you have, for each FlexFabric module, you're connecting into your SAN. So FCoE, or the fabric in FlexFabric, does not stack. It's a cable from each bay has to go to your fabrics. So you have SAN fabric A, SAN fabric B, east-west, A-B, whatever you want to call it. Your left fabric goes to fabric A, right fabric goes to fabric B. And then you've got 2 different shared uplink sets leaving the chassis. And this is the part I think there's a lot of confusion on. So shared uplink sets, 2 links, those could go to 2 different switches that are supporting VPC or stacking Ether channel. And you have that switch level redundancy northbound. Generally, that's LACP Ether channel when you're configuring on the northbound switch. And then you create these Ethernet networks and map them into that shared uplink set. So you see here I named them VM Management 1, vMotion 1, Pixie Boot if you're doing that, VM Traffic 1. That's all going to my shared uplink set 1, and then the same thing on the 2 side. When you're building your NICs, I have some slides that goes through the whole entire configuration at the end of the deck. You're going to assign your odd NICs or your even NICs to one shared uplink set and your odd NICs to the other. So the importance is you're going to have 2 shared uplink sets. You're not generally doing one uplink set out of the chassis for the whole FlexFabric. What we have here. It's kind of hard to see this from over here. I think I covered everything. So if you have questions, feel free to ask. So with FlexFabric, here's some different bandwidth options you have. This is one challenge I have with the whole VLAN tagging thing. Is you see, basically, if you do VLAN tagging with FlexFabric, you're going to start seeing multiple networks here, even if you're only tagging one VLAN. Again, you're in vSphere every day. I like the VLAN tags being in there. If you weren't tagging, you would actually see that Management 1, vMotion 1 right here in FlexFabric. But you see here, basically, you're giving it a set amount of bandwidth. So 500 megabits each for Management Console, 2.5 for VM traffic, 3 gigs for vMotion, and then you've got your storage. If you're doing IP storage, you can play around with the numbers, add yourself a 4th FlexNIC if you're not doing Fibre Channel or Ethernet, and give it 4 gigs or move that bandwidth around. You can change this dynamically on the fly. So like if you're doing maintenance and you want to let vMotion go a little faster, you can crank that up on the fly and allow your virtual machines to move a little faster. FlexNIC speeds today are outbound only. It also does not handle that inbound traffic, so you need to be aware of that. I think you're covered pretty well by setting these caps. vMotion is going to stay within that FlexFabric chassis, the stack that you're working within, if you're talking about 1 or 2 or 3 chassis. But again, this is outbound only, so be aware of that inbound traffic. LLD supported on vSphere 5. This is just a graphic of that. I like the distributed vSwitch with HP. Now we've got that visibility down to FlexFabric to give me information about what port I'm connected into. If you're using 1000V, I've seen this happen where people are starting to leverage the weighted fair queuing in 1000V with FlexFabric. I don't really like that model because with FlexFabric, you can actually support passing that cost value through tunneled mode. If you're reading their guides, you can enable tunneled mode, and the cost value gets passed through, but it's not doing any type of honoring of quality of service in that FlexFabric. So when we're talking about the oversubscription of 16 hosts going over 2 links, if you're doing the quality of service on 1000V, you're not really doing anything with that potential congestion point leaving the chassis. So my recommendation, if you're using FlexFabric with 1000V, which works, is to use the FlexFabric NICs to manage your bandwidth, because then you're ensuring that congestion is not going to saturate leaving the chassis. So 1000V, you should leverage FlexFabric for bandwidth throttling. the one thing I don't see people doing a lot, in the guide, the FlexFabric cookbook, they don't mention this. I recommend if you're going to be doing SandBoot or that portability of your ESX host or any of your profiles, also virtualize the UUID. It's referred to as the serial number in the options of FlexFabric. It says, do you want to virtualize the serial number? That's going to virtualize that UUID. We've seen some issues, talking to a peer of mine where they were doing moving out FCoE SandBoots of profiles on HP, and they lost a distributed vSwitch information. I think that's associated with that UUID. So UUIDs are very important on servers, and you can virtualize them on FlexFabric. The cookbook is very good. Read it, look at it. Again, you don't have to take it exactly as they configure, but it's got the step-by-step examples are really, really good in there on how to configure it properly. And then Insight Control for vCenter I think is pretty nice. If you install this and configure it, gives you a lot of great visibility into FlexFabric right there in the vSphere console.
Is that supported 4.1?
I believe so. Yes, 4.1, yeah. Nice option you can download and install. So John Reed from HP was saying the new version also gives you storage information in the Insight Control for vCenter. So good stuff, though. Install it so you get that visibility. Cisco UCS specific recommendations. Leverage I really like that virtual interface card in the Cisco's. So you can do Emulix or QLogic compatibility cards and leverage like network I/O control. But I like the virtual interface card with Cisco for that quality of service flexibility, which I'll talk about here. You got to configure QoS with Cisco. I've seen a lot of the documentation out there that kind of gets you half the way or a quarter of the way or two-thirds of the way, but I've not seen a lot of documentation that actually goes through each component of setting up QoS. I'll cover that for you, but make sure you've configured and tested it because you do need to fully configure QoS with the Cisco environments. I just have seen too many people that are kind of covering half of it. Leverage port channels and pin groups for uplinks. So basically when you're leaving your fabric interconnects, I've seen people doing a lot of port channels, which is fine. The 6100s going to 2 different 5Ks in a port channel. But I don't see a lot of people using pin groups. It's a simple step, and basically what you're doing is you're saying, I'm pinning this traffic to this port channel. So if you later introduce a second port channel, you're not questioning where your traffic's going. It's just a simple step. I've got a graphic picture on the pin groups, but basically you're just saying, I'm going to set up a pin group to this port channel, so I'm sending my traffic there specifically. If you add links later or do something else later, it's just guaranteeing your traffic's going where you want it to. So I like the pin groups, and I see a lot of people skipping that step. Updating templates. They got a bad rep with Cisco early on because the updating templates, basically, you can set a template in UCS that's responsible for all of your configurations out there on your servers. You could make a change, and it was very light warning, and your environment would reboot. They've addressed that very, very nicely with 1.4. They have a user ACK policy. You can set a user acknowledgement. It'll warn you once, and then after you've set your configuration that might require a reboot, it'll go in, and on each server you can do it one by one, or you can say go ahead and reboot all, but it's plenty of warning now. So the nice thing about updating templates is you've got one place to go to make adjustments to all your configurations out there. So I like them quite a bit, especially with 1.4 of UCS and higher. Enable CDP. It's not turned on by default on UCS. So just under the settings, turn on CDP so you get that visibility between vSphere and UCS configurations. So with Cisco, one of the things I find slightly confusing is this whole VIC card can be used many, many different ways. I can't tell you which way to use it. I can tell you the most popular I've seen right now is adapter effects, is what I refer to it as. That's the design I'll show you next. But that's basically you're presenting VMNix to ESX and setting quality of service there at the port group or vSwitch level. You can also leverage the virtual interface card with 1000V and leverage the host control. So when you're in UCS configuration on the VIC card, there's a button. A lot of people don't really know what it does. It says enable host control. What you're doing there is saying let Palo or that VIC card have the buffers, but honor whatever is configured in 1000V. So 1000V can do QoS, and Palo is going to honor the cost tags that are coming in from 1000V. The third option is the VMFX. It's actually pretty interesting, and I started testing it, and I like it quite a bit, but it's confusing, and I think people are still trying to grasp it. But VMFX is that dynamic VNIC. So with Palo, you can actually present virtual NICs directly to your VMs from UCS. Gives you a similar look and feel to 1000V. There's some differences between the two. But VMFX essentially is in UCS. It can provide virtual NICs direct to the VMs. There's a lot of confusion with this. A lot of people think that's the VM direct path, and you remove vMotion capabilities and all this sort of stuff. Dynamic VNIC, even in 4.1, you can still do vMotion with the basic dynamic VNIC functionality from UCS. And it's my understanding, I think with vSphere 5, they're actually supporting vMotion now with the VM direct path, but I don't see that commonly used right now. These are some formulas to be aware of. With the new Cisco stuff that just came out, I'm not even sure if it's shipping yet, the formulas have changed. Basically, in UCS in the back, you've got 4 cables. You can plug in up to 4 cables. If you're using things like VMFX, you need to know these numbers. Basically, you get 15 VNICs per cable. So if you got 1 cable, you get 15. The next one's 30. The next one's 60. And then they're all minus 2. So basically, it's 15 times the cable minus 2. So I thought I had examples, but 13, 28, 58, if you're using that model. The 6248 is a newer, it's 63 VNICs per cable. So with 2 cables, you're reaching the maximums of vSphere 5. And then if you want basically full network administration, one of the things I've seen, even with the virtual security gateway, it's still a VM, and there's still that little bit of thing between the network team and the server team of I want control. So the 1010 is really nice for that, and VMFX would give your network team full control over the NICs within your vSphere environment, if that's what you choose. So here's the quality of service values that I would recommend and how to configure it in UCS. I see a lot of this picture right here. I mean, that was in my slides last year, too. Quality of service, you have to configure these. The weighted portion, I think, is sometimes confusing. Basically, these can go up to a maximum of 10. All you're doing is setting shares, kind of like vSphere. And then you really want to focus on the weight. This is the percentage of the link that you're going to be giving to that traffic as a minimum guarantee. So you set these weights properly, and you're going to be looking at the weighted percentage as to what you're getting. If you want to enable MTU, jumbo frames, this is something I should have mentioned in here. I'll change it for tomorrow. But you need to set that to 9216. Some of the best practices I've seen, 9,000. So if you're doing VLAN tags with jumbo frames, you need that extra space for the VLAN tag information. So in this setting here, it should be 9216 if you're going to be configuring jumbo frames, not 9,000 that I've seen in some of the best practices. But right here, similar bandwidth, you see that it's a common theme for me. I think about 4 gigs between your storage. If you're using FCoE for SAN boot and NFS for your data stores, this would be good. If you're not using NFS, give your fiber channel 4 gigs of bandwidth. But VM traffic, I like to keep around 2.5 gigs of bandwidth. And then vMotion, again, on UCS, give it 1 gig minimum guarantee and allow it to burst. This right here, I don't think a lot of people know this. You can configure this QoS value right here in UCS and very easily copy and paste that into your 5Ks. And I think it's a great option. So with UCS, once you've configured this in the GUI, you can connect into NXOS inside UCS and just do a show run and config IPQoS. So show run IPQoS gives you just a nice section for QoS. You can copy and paste that into the 5K northbound. And I actually have that as an addendum, a reference. You can download that, just that simple config for this here. And so first thing you do is configure QoS. Second thing you do is you have to create QoS policies down below. So these are going to be applied to your VNICs. So you create these QoS policies, and there's that option of host control. If you're using 1000V and you want to use that, you can do it one of 2 different ways. You can let Palo be the VNICs and do different uplinks in 1000V, or you can enable that full option of host control to honor quality of service tags from 1000V. And you have your choices of, I actually turn the burst down on vMotion, drop burst to 0. We don't need it to burst, just let it do the bandwidth that it has available. And then lastly, as you create your VNICs, and this is the important part here, with the VIC card, you create multiple VNICs. So you can see here, I've got 10 virtual machine NICs. These are going to be, actually, ESX host NICs. These are going to be presented to ESX host in that standard vSwitch. You'll see 10 links instead of 2. And you just create different vSwitches, very similar to 1 gig designs. The important point is these are all different priorities in quality of service. So you see here, when you're creating your VNIC, you're assigning it to one of the 2 fabrics. Set your MTU size. Here's your updating template option. And most importantly is we're associating with a quality of service queue. So gold for management and the different values I've got right here. Lastly, 1000V. If you're doing 1000V, if you haven't already, I recommend Jason Nash's session. He's really, really solid on best practices for 1000V, but a really nice basic slide here. VSMs, you should have multiple VSMs, do a primary and a secondary. You have to disable DRS for the VSMs. I like the 1010. There's a lot of bundles that make it very, very low cost right now. Physically separate hardware for the control plane of your 1000V environment. VPC can consider IP hash where possible. In the blades, you can't, so you're going to end up using MAC pinning. On 1000V, you can, as of 1.4, configure QoS and do bandwidth priorities. So it'll be very similar to what you're seeing in the Palo card. 1.4 enabled the weighted fair queuing, bandwidth priority. Before that, you're just tagging the values, so you're not really doing much with it until it gets to the northbound switch. And then system VLANs, I see missed a lot. System VLANs, anything that needs to be available during boot of ESX needs to be configured as a system VLAN. in the downstream port profile as well as the upstream link. You need to configure it as it's a very simple system VLAN. Here's the VLAN ID, but you have to do that to ensure everything's available during boot with 1000V. And I mentioned the weighted fair queuing on 1.4. That's it. So summary. I hope you really kind of already had a picture of this, but understand kind of why you might want to consider 10 gig in your environment. Hopefully covered for you some of the considerations you might want to have when you're thinking about 10 gig. And then lastly, I've got some good best practices in there. And then after the deck, I have screenshots of configuring HP and Cisco UCS all the way through. If you want any of this material before the 2 weeks are available, shoot me an email or get me on Twitter. I've got my contact info here. I'll happily send you anything. I've got this gear available if you guys want to play with it this week informally. Offline, you want to see anything, I'll show you anything I've got. And I hope you guys enjoyed this session. And here's my links and references. Tons of good links out there. The one right here, we've got our Dropbox we've put out there. I've got a lot of good material in here, slide decks, and then some spreadsheets I use to do the calculations in this. You can tweak them in Excel and then paste them into your, and then go in and put them in your configs a little quicker. But lots of good docs to read over and look at, both for HP and some stuff from Cisco. I've also got slides from Cisco Live from Brad Hedlund and Sean McGee, which were really, really good deep dives on Cisco UCS. And here's my contact information. Thank you guys for your time, and I'll certainly take questions afterward.